Welcome to Lesson 1.4, Learning Target 1, Graphing Absolute Value Equations by Hand. This is a supplemental video for those of you who may still be struggling with this concept after we've gone over it in class. We looked at several examples that led us to the following steps when we go to graph absolute value equations. The very first thing is that we want to find where the center of the absolute value equation is. And so we looked at an exploration in class where if we had absolute value of x minus 3, we saw that the bottom, which we're going to call the vertex of the v, or sometimes the top, depending on whether the v opens up or down, is at positive 3, even though the equation was minus. And so our first step that we looked at was that we know where that point, where the center of the graph is, if we set the modulus equal to 0. So if I set x minus 3 equal to 0 and solve, I get that x equals 3. And that's where the center of the graph is. So we start by doing that to figure out the center value of our table. So let's take a look at this example that has multiple operations. So we can look at how to do this one by table. Our modulus is 2x minus 3, which means that 2x minus 3 equals 0 will help us get our center. If I add 3 to both sides, I get 2x equals 3. And when I divide by 2, I get that x equals 3 halves is our center. 3 halves is 1.5. So I'm going to want numbers to the right and left of this in my table, and I'm going to want this number in my table as well. So as I make my table, I'm doing this on extra large paper for you, we have 1.5 in the middle of our table. On our graph, we look, 1.5 is here, at least 2 values to the right. So I'm going to do 2, 3, I'm going to do 3 this time. I'm going to do 2, 3, and 4. At least 2 values to the left of 1.5. I'm going to do 1, 0, and negative 1. So I'm going to do 3 values to the left and right. We expect the center to be right there at 1.5 as our x-coordinate. Now the order of operations, when you go to graph an absolute value equation, you're going to follow the order of operations. You do everything inside the absolute value symbol first. So you basically plug these numbers into the modulus first. Then you take the absolute value, and then you deal with multiplication and then addition and subtraction outside. So the very first thing we're going to do is 2 times x minus 3, because that is the modulus. We're going to do that for every one of these, plugging in negative 1, and 0, and 1, and 1.5. So I'm just going to keep copying this because this is exactly what I'm going to do to all of these numbers. I'm going to multiply them by 2 and subtract 3, just like the modulus says. So when I plug in negative 1, I multiply this, that's negative 2, minus 3 is negative 5. Multiply by 0, 2 by 0 is 0, minus 3, that's negative 3. 2 by 1 is 2, minus 3, negative 1. 2 by 1.5 is 3, minus 3 is 0. 2 by 2 is 4, minus 3 is 1. 2 by 3 is 6, minus 3 is 3. And 2 by 4 is 8, minus 3 is 5. I am not done. All I've done was do what the modulus was, which was multiply x by 2 and subtract 3. Order of operations, multiply the x number, the number that you plug in for x by 2, and subtract 3. Now that I've done the modulus, I have to do the absolute value of all of these. Absolute value of negative 5 is 5. Of negative 3 is 3. Negative 1 is 1. 0 is 0. 1 is 1, 3 is 3, and 5 is 5 when I'm doing absolute value. So now we followed this equation. We multiplied by 2 and subtracted by 3 in the modulus. We did the absolute value. Now we have 2 other operators out here. we have the multiplication of -2 with whatever number comes out of the absolute value, and the addition of 4. So we're going to take these numbers and multiply them by -2 and add 4. And I have to do that for each number that came out of the absolute value. So I have to do that for 5, 3, 1, 0, 1, 3, and 5. And you already know that these are both 5, and these are both 3, and these are both 1. So whatever I do to these top 3 is going to be the same output down at the bottom. -2 times 5 is -10, plus 4 is -6. -2 times 3 is -6, plus 4 is -2. -2 times 1 is -2, plus 4 is 2. -2 times 0 is 0, plus 4 is 4. Again, -2 times 1, -2 plus 4 is 2. There's 6 plus 4, or -6 plus 4, -2. -10 plus 4, -6, just like we have above. This gives us our ordered pairs. Our ordered pairs will be -1, -6, 0, -2, 1, 2, 1.54, 2, 2, 3, -2, and 4, -6. Those will be our ordered pairs that we need to graph for this function. So on my graph paper, I will plot -1, -6. I'll plot each of these points, and I'll show you that in 1 second. When I'm done and I graph, I should see that top or bottom of the V at the 1.54, and then the shape should be a V. If it's not, then I've done something wrong in my operators. So this is the graph of y equals -2 times the absolute value of 2x minus 3 plus 4. We plugged the numbers for x in after we found the center by setting the modulus equal to 0. We found the center would be 1.5. We put the center of our table there, plugged in all of these numbers, multiplying them by 2 and subtracting 3, then taking the absolute value, then multiplying by -2 and adding 4 to do the operators that were outside of the absolute value. Stay tuned if you'd like to see one more example of how to graph these using a table. For our next equation that we're going to graph, we have 3 times the absolute value of 2x minus 1 minus 4. So again, we need to figure out where the center of this graph is going to be. We're going to set this modulus, 2x minus 1 equal to 0. I'm going to add 1 to both sides, 2x equals 1, and divide both sides by 2. X equals 1/2 is the center of the graph. We're going to want to make that the center of our table. So as I make my table, I'm going to put 1/2 at the center of it, 0.5. To the right of 1/2, I'm going to want at least 2 values. I'm going to do 3 for this video, so I have 1, 2, and 3. To the left of 0.5, I have 0, -1, and -2. The operations that I need to do first are the operations. I have to do everything in the modulus first. In this modulus, we have 2 times x minus 1. So that's exactly what we're going to do. 2 times our number minus 1. And I'm going to do that for every single one of these. This first one gives me 2 times -2, which is -4, minus 1 is -5. 2 times -1 is -2, minus 1 is -3. 2 times 0 minus 1. 2 times 1/2, which is 1 minus 1. 2 times 1 minus 1. 2 times 2 minus 1. And 2 times 3 minus 1. And I get, in this case, because the numbers are very similar to the ones I had last time, I have -5, -3, -1, 0, 1, 3, 5. I did what was in the modulus. Now I'm going to do the absolute value, because that's what this equation, that's how this equation is wrapped up. 2 times the number minus 1, do the absolute value. After I've done the absolute value, the other operations are to multiply whatever number comes out by 3 and subtract 4. So we'll deal with that in a second. Right now we're just doing the absolute value of each of these. Absolute value of -5, -3, 1, 0, 1, 3, and 5. This one's, it always comes out positive or 0. So 5, 3, 1, 0, 1, 3, 5. So that's what we've gotten after we've done the absolute value. Now we take each of these numbers and multiply them by 3 and subtract 4. So 3 by 5 is 15. 15 minus 4 is 11. Not going to fit on our graph. That's okay. 3 by 3 minus 4, that's 9 minus 4 is 5. 3 by 1 minus 4, 3 by 0 minus 4. Look, we've got the same numbers down here. 3 by 1 minus 4, 3 by 3 minus 4, 3 by 5 minus 4. I already did this one. This one is 11. This one is 5. 3 times 1 is 3, minus 4 is -1. 3 times 1 is 3, minus 4 is -1. 0 minus 4 is -4. I won't be able to graph all of these because my graph paper doesn't go to 11. I suppose I could put an extra tick mark on it if I wanted to. So on my graph paper, I'm going to plot the following ordered pairs. I'm going to have -2, 11, if it'll fit, -1, 5, 0, -1, 1/2 or 0.5, -4, 1, -1, 2, 5, and 3, 11. And I should see that V shape. If not, I've done something wrong. So I have -2, -11, -1, or wait, that's -2, 11. Sorry, -2, 11, not -11. -1, 5, 0, -1, 1/2, -4, 1, -1, 2, 5, and 3, 11. And I see my V shape with the vertex of that V being at 1/2, -4. I have the correct graph for an absolute value function. There is an additional example in this packet. It doesn't have the video, but it does show you step by step what operation was done to get the numbers to make the graph. Hopefully you found this video helpful. Again, the learning target was for you to be able to graph absolute value equations, not by hand, but by table, using a table. Have a great day.